I am surrounded or accompanied by three very, very distinguished experts. And again, thank you for being here. I will do my best to attempt an engaging and exciting discussion on artificial intelligence, and I'm going to start with the basics. Let me start with Dr. Harvey. What is the value of artificial intelligence? How can it augment the cognitive decision-making processes?
All right, thank you. So great question. I'll draw back to some of the experience that I have across the DoD, but also bringing some experience from industry, working with Fortune 100 and 500 companies and organizations. And one of the biggest things that organizations really are having problems with, if you think about just the large amount of AI and machine learning capabilities that are being introduced into these organizations, is really after you do the comprehensive data engineering that's required to kind of really build data sets that are fit for use for machine learning. There's been a plethora of organizations that have introduced machine learning platforms for building world-class models. But one of the main challenges that we're seeing is really the inability to take those machine learning algorithms and bring them to life inside of applications, which a lot of organizations coin the last mile of AI and machine learning. So really, the organizations that are in the Department of Defense, they're really focused on how can we have human in the loop machine learning and artificial intelligence, where there is a final individual that triggers the machine algorithm to run. What we're seeing in some of the industry organizations, they want fully autonomous machine learning and artificial intelligence, where the machine learning is essentially being triggered by other internal processes that are non-person entities. So when we talk about augmenting the cognitive decision-making process, it's really, how can you integrate those technologies into the application so that you can empower that data-driven decision-making, right? Where you have a human in the loop, and the human that's in the loop can really use the insights from the machine learning and the artificial intelligence to support them in their day-to-day activities.
Very good, thank you. Dr. Gregory.
Thank you. Wow, that's such a great question. Artificial intelligence is broadly being used, and even more so today, in medical health decision-making and understanding the structure of data and annotating data and annotating images. I can give you one example, but this is just one of many, many activities that we're doing at NIH, but it's one of my favorite because, well, my office funded it. So of course I like it, but it just sort of gives you a sense of some of the challenges and what we can overcome with AI. Most data is not what we would call AI ready. It's just a big mess. We would and could and we can go out and regenerate all that data, but there's a lot of value in the data that we have and making it sort of what we would say AI ready. And so in a particular example, this is Dr. Gilman at the University of North Carolina, Chapel Hill. He's looking at kids who are at risk for mood disorders, and they're young. They're between the ages of 1 and 8 years old. And he's doing MRI brains and other brain scans as part of a brain initiative on these kids to see if he can look at brain patterns during activity and pick out what might be key factors for mood disorder and for at-risk kids. But doing time-dependent studies on kids is hard. You're challenged with parental, priorities and kids being able to come in. So what he does is he augments the missing data, doing sort of data imputation with those images. And that's really helping him utilize both new ways to think about missing data and new ways of generating AI and image detection to really look at what might be at-risk kids for mood disorders. That's just one example, but I have a whole bunch of those in my back pocket. And that's really the benefit of AI, especially, and I'm sure that we're going to hear about the way that you can utilize it for really high throughput annotation of images, but I could talk about high throughput annotation of genomic sequences, same idea, pulling from the literature and annotating genes. We used to have to read those papers. And you don't have enough grad students in your lab to annotate genes. But now we can really think about that with AI, but later on, maybe we'll talk about all the challenges that represents with missing or incomplete or erroneous data Thanks for the question. It's a great one.
Oh, wonderful. Thank you. Dr. Plez?
I like to think that this is a problem we've created for ourselves. In the last 30 years, people have talked about this as the era of the computer, and there's something called Moore's law, which is the continual speed up of computing, like doubling in speed and capacity every 18 months. And that's held true for a very long time. And the amount of data we've created has grown even faster than the amount of computing. And so in some ways, the fact that we're drowning in data is our own problem. And AI is kind of the family of tools to try to address that. And so hopefully we can solve this problem we've created for ourselves.
Well, the problem also creates some opportunities. Could you share some examples of where you have applied or are looking to apply artificial intelligence?
Absolutely. So I've been interested in understanding images for a very long time, and images are one way of capturing representations of the world. And one of my favorite projects to work on, because it has such a big potential impact, is a project where you're trying to index the images of hotels all around the world to be able to find sex trafficking victims that are sometimes imaged in hotels as part of an advertising process. And so I think 10 years ago, the idea of trying to say, here's a picture, it was taken in a hotel, which hotel in the world was it, would have been really infeasible. And some of the modern techniques to AI, especially in creating indexes of imagery that are searchable, work to identify the hotel, and also similar techniques work to identify maybe conditions in MRI images. And it's a really neat convergence of the tools, mostly which have been built on really interesting mathematical fundamentals that makes them applicable to such different domains, that has driven a lot of the progress.
I love that. That's awesome. That's really cool.
And it is cool. And thinking about NIH, where you have perhaps the greatest access to the greatest volume of data sets around health, and you're just starting to unlock these with new tools. Some examples there, please.
Yeah, absolutely. We have, just a plug for our own work, we have over 206 petabytes of data on 3 different clouds, Google, Amazon, AWS. That's just the data that people are openly sharing through either data platforms or just through putting the data on the cloud. There's a whole bunch of dark data that that is generated through part of research that may or may not be shared, that might be locked up in publications. That data really has the benefit of fast forwarding artificial intelligence to a degree that we haven't seen before. There's an example, I love this example. It's looking for rare diseases in newborns. Your child is born and it automatically has a phenotype that indicates that there's something wrong. You have to do a whole genome sequencing. And then you have to compare that genome sequence with genomes of existing rare diseases to try to find that. Researchers have been doing that sort of comparison of genomic sequence and augmenting that with natural language processing and AI of the clinical records to try to really quickly match the phenotype of the baby along with the potential phenotypes extracted from machine learning, and then trying to match that with the kid's genome, and then quickly getting the therapeutics to the kid. And we can do that now because of AI in about 5 minutes. That would have been like a week's, I just described to you what was probably a week or a month's worth of really intensive work to try to get a therapy to a newborn. That's in 5 minutes. So, I mean, just what can be done now is pretty unprecedented. That doesn't mean that there aren't challenges, but I think there's an amazing opportunity with artificial intelligence that we've just unlocked.
And you're really just starting in a lot of ways.
Yeah, absolutely. Yeah, we're literally just starting. I think this is for us. Maybe we've started Bridge to AI this past year. We started Aim Ahead 2 years ago, and then we have a lot of funding opportunities in artificial intelligence across NIH. There certainly is a lot in aging and Alzheimer's and brain research, but just in general methodologies through either the National Library of Medicine, which is very interested in natural language processing, or in general medicine, where I came from, which is the sort of basic computational side of NIH. So I'd like to encourage you to look at those opportunities at your leisure, and maybe talk to program staff about where you can apply your work to solve biomedical problems.
Outstanding. Thank you. Dr. Harvey, I'm trying to think of how you're going to limit yourself to 1 or 2 examples. You have such a plethora of experience. What are some good ones in your mind, please?
Yeah, so in a past life, I was the head of data science for the Edward Snowden leaks. So I'll give an example from the NSA, but before I do so, I'd ask everybody to turn off their phones, turn off your computers. So I actually won't go down that route, but I will give it an example from industry, working with some of our Fortune 100, Fortune 500 customers. And, there's an emergence of, organizations that really want to use, large language models and conversational AI. And one of the challenges is that, how do you help the large language model understand the intent of the users in the organization, right? So there's a lot of organizations that are interested in trying to help the AI and machine learning capabilities have additional contextualization into the actual prompt as well as the responses. So one of the examples that our company kind of brings into the mix for these Fortune 100 companies like Vanguard is that we're helping them start to harvest data and information directly from the DOM or directly from the HTML inside of these applications and feed that into the large language models to provide additional context for a more personalized response from these conversational AI capabilities. So it's really about, adding that additional context, and that additional context really continues to augment, right, that decision-making process directly inside of their field of view in these applications.
Very good. No, that's a great perspective on that, and also very unique. Having that NSA perspective is quite something. Why don't I come back to Dr. Pless and ask the next question, please? What are your thoughts about emergent AI trends and technologies? Are there specific risks or concerns related to your work, such as biases?
Sure. So I think one of the biggest emerging trends, maybe in the last 6 months, is the availability to almost everybody of some of the tools like the large language models like ChatGPT, or the image versions of something similar like the DALL-E make an image tools. And I think anytime something becomes available to everybody, then the opportunities and the benefits and the risks all multiply like crazy. And I think we're seeing some of that there's so much excitement. And it's some of these tools are so novel and so sort of unbelievable compared to a couple of years ago that many societal expectations about things have changed, right? It used to be if there's an essay written about something, somebody had to spend hours writing that essay. Maybe somebody you paid to write it for you, but somebody had to spend that time. And now it's like 4 seconds, right? And so I think there's a lot of ways that we have sort of expectations and traditions that create barriers or create when you get something written, it used to mean that somebody spent some time writing that, right? And now it doesn't mean that. I think that
it was very obvious that a human generated that, and it took a certain amount of labor to do that. And
exactly,
there was no other way to generate it.
Exactly, and that proof of effort was sort of an important milestone for many things, and now it's not. And I think we have a lot to do to understand the implications of that.
The things that we assumed are no longer things that we can assume.
Correct.
Dr. Gregory?
Yeah, absolutely. I have 2 examples. You probably are aware, because you're all computer scientists, that ChatGPT was trained on, I know, billions and billions of text from the web and from PubMed, perhaps, and other resources. It's over $100 million on AWS. It took a lot of cores. That's not something that we can easily do. I think that it trained up to the year 2001 in terms of the data entries. So that in and of itself is a computational challenge. So what I've been noticing, and I certainly would love to see more of, is researchers sort of doing not sort of super large language models, but tractable language models. I've looked at folks who are doing, for example, training language models on Mimic, the Mimic 3 and the Mimic 4 data set. That's a really highly curated biomedical data set that you can actually parameterize, in a realistic time. And my hope is that maybe some of these more specific language models will feed into the larger language models, because I think that we have the opportunity to see a lot of unintended bias. I'm sure that you've run queries. You can do what, for example, when was the first Bayesian paper ever published? And ChatGPT will give you an absolute answer. It likes to please you. It's the librarian of Google, they say. And so the librarian will bring you an answer. It may not be at all correct or even realistic. There may not even be a citation there but it will format it for you. And so this is definitely something that I think having a risk assessment or risk frameworks, and I can talk a little bit about the NIST risk framework and ways that we can develop trustworthy AI to really hone that in. I have another example, but maybe I'll pass so that we don't run out of time. But if you're
We'll come
interested,
back.
I'll come back and I'll tell you another one.
You got it. Dr. Harvey.
Yeah, so so at the National Security Agency, many of the Department of Defense organizations, there's different stages in the machine learning lifecycle, and in each one of those stages, from the data engineering, machine learning, all the way through utilization of the results, there's inherent biases. And what the NSA and a lot of these DoD organizations that we work with, AI Squared, what they try to do is they try to build in different tools that can help kind of manage that entire machine learning lifecycle, right? So if you think about building world-class models and the bias that might be in the models themselves, they have machine learning observability tools and capabilities that can help you kind of monitor the hyperparameters within the algorithm so that you can kind of weed out some of that bias and in building and kind of adjusting the parameters to build that world-class model. And the same thing with the data. But they also put in, these very, large government supports that are, subject matter experts in the field of, let's say it's a CNN model, they'll bring in a subject matter expert from the realm of convolutional neural networks that will provide direct subject matter expertise to help them understand when it is the right time to actually deploy that machine learning model in a mission production system, right? So they bring together, kind of people, processes, and technology in a way where they can start to kind of identify the models that are ready. But in the end, they're providing mechanisms to start to help the end users understand if the model is actionable, is it relevant, is it timely, is it contextualized. So putting all of that together really fosters that trust from an end perspective.
Absolutely. That was terrific. And let me stay with you. I'll come back to the next question, maybe try to establish a segue here. For each of your respective roles, and you have many, Dr. Harvey, academia, government, and industry, how do performance targets or trust in the algorithm drive your work? Who do you have to prove your system to?
Yeah, great question. So I think, for us, it depends on our customers. But what we're seeing is in a lot of instances, the overall goal is AI adoption, right? So in an organization, you want your AI and machine learning technology to be broadly adopted, right? And some of the metrics that are associated with adoption are things like, what's the amount of usage? What's the amount of engagement? What's the amount of productivity or efficiency gains that the AI and machine learning is providing for the overall organization? And in order to kind of really get that increase in the adoption, it's about how can you make the experience of the AI and the machine learning, the best throughout that organization. And the ways that we're seeing that is it really starts to come into play for organizations who are building kind of human in the loop AI and machine learning technologies, but ultimately are interested in that human machine teaming aspect of using AI to support that data-driven decision making. So what organizations are now starting to do is they're starting to measure, things like, how, you ask the question from your end users, how actionable, right, was the results of the machine learning? Did it actually support you and your workflow, right? So you're getting not only quantitative, right, as far as the accuracy and the performance, but you're also getting qualitative measures of AI and machine learning to help the organization understand the impact and the value that the AI is having as well.
Very good. That's great. Thank you. Dr. Gregory.
Thank you. Well, we're probably, because we are a government funding agency, for the most part, we do have intramural research and clinical research, but for the most part, we're the funders. I'd say that we're accountable to you, the taxpayers, to make sure that we're funding the best science. And I'm sure that the scientists are, working towards reproducibility and trustworthy AI, certainly a goal. I would say that for us in my organization, in my office, we work pretty strongly on building that framework for AI that's ethical and trustworthy and bias-free. We have a number of programs. One of our larger programs is aimed at increasing the accountability and usability of AI in underrepresented communities. So AI and the development of AI is pretty strong in campuses like this one and Stanford, and not so much in Louisiana State. So our goal with the aim ahead, which is really to increase the diversity of both the data sets and the researchers developing the algorithms, as well as the communities that are impacted by AI in underrepresented and under-resourced communities, working with historically Black and Hispanic colleges, universities, and schools, as well as tribal communities. It's a network of over 120 institutions across the US, over 500 academic PIs, and over 1,000 trainees, all learning how to make data AI ready, learning how to develop AI algorithms, and then working with the communities, not actually researchers, but like church communities or barbershops, to really understand what are the needs and the use cases of those communities and how AI can help those communities. So I'd say that in that sense, we are accountable to those communities to make sure that they're included in the data sets, that their use cases are included in the work that we're doing, and that the researchers that we train can go on to have careers. And I have to say, we've had one success. It is a small one, but one of our assistant professors in our program recently was awarded a NSF Career Award. And so for us, that's an achievement. We have somebody who's going to be a successful computer scientist and AI researcher who can get funding at NSF and at NIH. And so small steps, but I'm proud of them.
Well, it's also remarkable how wide you have to go across your biomedical research ecosystem to try to level the field, try to be as unbiased as possible. It's a very difficult endeavor. It's not just the data.
Oh, absolutely. Absolutely.
So thank you. Dr. Pless.
Yeah, so in the academic world, we have the mandate to try to push the state of the art to new things. And I think that has made the evaluation of machine learning so easy for so long. Because, for example, Google search is one of the classic examples of machine learning, and it's been really successful since 2003 or something, because it was solving a problem that nothing else solved. So if your Google results were bad, we were all trained to believe that we put in the wrong search terms, right? And there was no alternative to searching the billions of web pages. So whatever it gave, sort of that was something we were okay using. And the computer vision field is similar. My first time at a computer vision conference, CVPR, was 97. There was 126 people there. And I'm program chair for it next year, and we're planning on 16,000 people, because this actually works now as a thing that really goes out into the world and affects things. And that means the criteria it's judged on is no longer like proof of concept. Maybe this works sometimes, or here's some cute formulas and they really work on images, but we actually deploy things in the world and they affect real people. And that means the accuracy and performance just is measured in different ways that have to be handled. And I think some of the new fields of research that are coming out, like trustworthy AI as a field of research, is trying to say, now that we are here and we have these systems, let's try to understand the representations and tools and algorithms that can also make them trustworthy. And I think our other mandate as academics is to our students. And so beyond developing new algorithms and research, we also have to develop new curriculum and programs to try to make sure that the students get the access and the exposure to the good and bad and nitty-gritty of all these tools also.
If you're now hosting 16,000 people, do we get to call you rock star? I mean, really, that's incredible growth.
The sound system has certainly gotten better.
That's wonderful. Thank you. And just to share with everybody here, we have time for about one or two more of the questions that I'll ask, and then we'll turn it over to you, the audience, both virtually and in person. So have your questions ready if you don't already have something ready. Let me start. Great segue going towards the discussion on trust and artificial intelligence. Dr. Gregorek, let me turn to you for this next question around trust. People seem to be excited about the utility of large language models like ChatGPT that contain a great deal of knowledge. But Dr. Gregorek, you've brought up an important, I'm sorry, let me reread this. You brought up the important contributor to distrust in AI is that these programs can also include biases and inaccuracies. What can be done about this?
Oh, I think that's a great question. And I would say that if I were starting out now as an undergrad or a new grad student in AI, that would be the thing I'd really be interested in, is the intersection between, computer science and AI, and a little bit more harder concept to grasp, which is trustworthiness. I think there's a lot of good work that can be done in mathematics, computer scientists, as well as potentially ethics. And we've been working for a long time to bring together those communities of for us, biomedical data scientists, computer scientists or data scientists, and bioethicists. And I think that you'll see probably much more push. I'll give you an example of why this is important. And this is published from 2019, so it's a little bit old, but it's still relevant. IBM wanted to try to determine if there's a way that they could use Medicare and Medicaid records to look at who would be most likely to have postpartum depression. It's a problem. They had over 7 million participants in their record system. And what they found after parameterization and normalization was that white women had much more likelihood of both having postpartum depression and then seeking treatment. But in reality, it's not a race thing at all. White women and Black women have, and other people of color women have the same propensity of having postpartum depression. What the underlying data that they train their models on was that in Medicaid and Medicare, white women tend to go and seek treatment. And so they're in the record system. So what did this tell us? The AI is really good at telling you the underlying structure of your data, and that if your data is missing important people, you will get the wrong conclusion. It's the same for large language models. And so I think for us, how do you know a priori or when you get a result? Is that because the data is biased, the algorithm is biased, or is that a real result? I think that's maybe a harder problem. This one was easy, and even the authors of the paper knew the outcome. And I think maybe the point was to show that you can have a super large data set, but if it's biased, you're gonna get a biased result. And so trustworthy AI is certainly something that we're very interested in. There's talk about this not just in the US, but also in the European Union with new ethical AI frameworks that have come out. And then NIST with the risk management assessment of AI is a really great tool to look at risk for people, risk for organizations, and then risk for the ecosystem. They define the ecosystem like the planet, or the supply chain, or the economic infrastructure. So I think that there's just a lot of work that can be done. I don't have more questions and desire than actual answers, but thank you for asking.
No, but it's an exciting time and a challenging time, and something we'll look back on sometime and see how we resolved all this, hopefully.
Absolutely.
Dr. Harvey, thoughts on this?
Yeah, so inside of Fortune 100 financial service companies, for an example, in Vanguard, before they deploy a model fully into an operational environment, they'll run, a 4 to 6 week observational study, right? And inside of this observational study, they will bring together a group of, end users, a group of, technical experts that are responsible for kind of evaluating the model in a as close as they can get to a live production environment. And what this provides is the ability to kind of really study the model and study the algorithm so that you can, start to apply your, during that end-to-end machine learning lifecycle, your, observability techniques, transparency techniques, your explainability techniques, so that you can really understand how well the model would actually perform in this production environment. So after the 4 to 6 week observational study, then they fully deploy the machine learning algorithm inside of that production environment. And what this starts to do is that, a lot of times we talk to these end users in these financial services organizations, and they'll say, hey, we never used the results of the machine learning algorithm because they were stale or they were inaccurate. And for the first time, what we're starting to see is as these organizations are running these iterative observation studies with the end users are providing feedback, right? And that feedback is really providing them with the knowledge and the understanding of how the organization is training the model models, but it also gives them the trust that they're being heard, right? And that's really important because now that they're actually seeing the feedback being put into the actual machine learning algorithms, and they're seeing the results of that come back into their workflows, that iterative kind of feedback is really part of that trustworthiness in that machine learning lifecycle.
Very good. Thank you. Dr. Bless.
I think Dr. Harvey, you're emphasizing the feedback loops, and Dr. Gregory, you talked earlier about the human in the loop, and I think those are the critical way that we're going to try to address bias in the AI systems, because the AI system is going to have bias reflected from the data set it was trained on. And I think the key is to not have computer scientists leading the charge in deploying these systems in real world environments. Our dean is sitting in the audience, and he's pushed engineering and as a theme for GW engineering, with the idea that engineers have to be outward looking and have to say, we build tools and then we work with the people that try to deploy those and implement those in the real world. And I think that the key to really effective AI tools that address all these human issues are going to be combinations or results of combinations of computer scientists and engineers and data scientists, and also the transportation engineers or the medical experts. And that's the only way it can work going forward.
Very good. And so while you're here, the last question before I turn it over and start asking the audience questions. What are the opportunities for students, for graduates, just in general in artificial intelligence? What is your vision? We are here at the George Washington University. Where can our audience expect to find opportunities in artificial intelligence?
Absolutely. So I think that's going to become bigger and bigger across the educational enterprise. Here we have two classical degrees that really are good focuses for this. We have a computer science degree and a data analytics degree at the master's level, and a computer science degree at the PhD level, and undergraduate degrees, I think, on all those things also. We've also recently created a special 4-course graduate certificate, which gives specific training and credentials in the area of trustworthy AI. That's targeted for anybody who wants that, but maybe especially sort of mid-career specialists that are trying to learn about this thing that is affecting so much of the business processes right now. Those would be the places I'd point people.
That's encouraging. Thank you. Dr. Gregory, you have the largest biomedical research resource in the world up here in Bethesda, Maryland, not too far away. Opportunities for students and graduates there.
Oh, absolutely. We bring in both graduate students and even undergrads to work in the summertime. We are standing up a data science program that will look at postbacks coming for a year internship. Certainly interested in computer scientists, data scientists to come to Bethesda. We also have opportunities for newly minted PhDs to come as postbacks, or folks who would like to do a little bit of a sabbatical, either from academia, from industry, nonprofits, to come and work as a data science and technology fellow. It's sort of like an NSF rotator, but at NIH, and instead of necessarily running large programs like you would at NSF, you work on really hard and challenging data science and computational problems. For example, we have one right now that's open, I think, until the middle of May. Is it the 13th? 15th, May 15th. It's open until May 15th. You can come to NIH and work in our institutes and centers on large language models, on data integration, on ways to look at publication. We have something called Litcoin, literature micropubs, and standing up ways to integrate that data together. You can work on genomics data. So we have a lot of opportunities for folks to come sort of as a 1 or 2 year sabbatical at NIH. So all through the pipeline, we bring folks in to work at NIH, but because most of us are in the computational field, working at NIH might mean working remotely, but still participating in your work. You just might not physically be there. And I think there's a lot of opportunities, especially for younger people. So I hope that you'll look into these.
That's great to hear. There's definitely need and growth. I think that's pretty apparent. Dr. Harvey, you straddle industry, academia, research, thoughts?
Yeah, so as part of, so I am a research professor here at George Washington as well. And as part of the designing trustworthy AI systems, we participated and actually helped create a program called Hacking for Intelligence. So it's a partnership with the National Security Agency AI Squared, George Washington was a partner as well. But we also had about eight HBCUs, historically Black colleges and universities and minority serving institutions that were a part of this Hacking for Intelligence effort, where we worked with the National Security Agency, brought in challenge problems. So some of the NSA's most challenging AI and machine learning problems, and worked with about, I think it was 30 students over a semester to really, help them, from the ideation process all the way through to building prototypes. And we worked through, George Washington did an awesome job of helping and support that effort. And in the end, we presented the ideas and the prototype technologies back to the National Security Agency. So there is opportunities for students if they want to participate in that Hacking for Intelligence effort that was co-sponsored by AI Squared and George Washington. That's always an option.
Outstanding. Thank you so much. We can keep doing this, but we're going to turn to the audience now, which is really the heart of all of this. So for anybody here in the room, if you have a question, I'm going to stand up and walk the mic over, and we'll alternate with my colleague who will be doing some remotely.
My name is Neil Wassman. I'm a member of Dr. Pless's enterprise and an admirer of Dr. Pless in particular. No, because I think he set a model for having socially consequential computer science. The question I'd like to ask is about the incentives that could be imposed to develop ethical AI systems. And we can stipulate that AI has enormous potential for good. It also has enormous potential for risk, designer weapons, misinformation, all kinds of risks. The best framework for AI assessment has been fairly recently produced by NIST. There's a NIST framework and playbook for risk assessment, and that's based upon the environmental model for risk assessment. And a little bit of a warning is that the environmental model for risk assessment has, I think, in most ways been really kind of a failure. That climate change has not been addressed by the risk assessment process that has emerged in an environment. And AI has the advantage that the change is dramatic in contrast to environment. Okay, so I'm sorry for the length of the question. So what I would ask is, asking NIST to be responsible for AI ethics and risk is like asking NOAA to be responsible for climate change. We need to have a much more robust incentive structure for risk evaluation and action. And I was just asking, my question is, what would be your creative ideas for that framework? How could we encourage the appropriate incentives for proper behavior in the application of AI?
So my response to that would be to notice that for a lot of the AI applications, the barrier to entry for different approaches or companies is relatively low compared to many other industries, right? So we all drive cars, and the country is sort of organized around cars and highways. And until electric cars became feasible, what would you do to try to minimize your climate change impact, right? Like you'd find a higher mile per gallon car or something. Here, like there's OpenAI, ChatGPT, Bing has a version of the large language. Like there's already a huge number of competitors, which means that as the general public or as institutions choosing an AI provider, we have choices. And I'm hoping that people who care about this relentlessly advocate to choose the models that have the least of that sort of larger scale social risk, and therefore benefit the companies that are making the socially responsible choices. I think that's one part of a much bigger answer, but that's what gives me hope so far.
Yeah, I think that is a great question, and you're right. The NIST framework is a framework that certainly could be improved upon. I think that you're right that sticks may not be the necessarily only or right approach, but incentives. Certainly when we see things published, we'd hope that there would be some really good peer review, especially in terms of the training. And I would love to see when people are publishing artificial intelligence that they're also algorithms and methods and papers, that there's also a component to that publication that talks about the risk assessment and what they did and how they actually address bias and transparency. If we as a community hold people to that standard, I think we will start to see that. NIH has peer review for grants. You know, we're not the largest funder of computer science, but I hope that this idea will trickle in terms of when you're developing work, that you do have some kind of assessment plan for how you're going to mitigate risk and bias, and that certainly, as you say, in the community at large, that people do vote with their feet. And so that if you're finding that there's an algorithm that's giving you an awful lot of erroneous results, perhaps there's better choices. I hope that sort of helps address your question.
It's a big question.
Do we have any questions remotely?
Yeah, so we can start with a question online from Paul. So if you could each in your field speak a little bit to how we are measuring trust in AI currently, and maybe a little bit about how we should be measuring that trust. Maybe it would be useful to identify some metrics or dimensions of trust that you see in your work.
Yeah, so I guess one really good example is the feedback loop that we've seen at the Vanguard group, right? Really where you know, the organization came to, you know, AI Squared, and they said, hey, you know, trust is a big problem. And that's affecting the overall AI adoption, right, inside of the organization. And, you know, the first thing that we had to do in order to help them understand how to increase trust in overall AI adoption was to figure out when end users in the organization are leveraging AI and machine learning, what are the attributes that could help them ultimately make a decision on those insights? And we start to get things like, you know, are the results contextualized? Can I map back to the underlying training data that was associated to how the model made the decision, right? From a relevancy perspective, you know, a timeliness perspective, all the way through the actionability of the machine learning and artificial intelligence capability. And then we talked to leadership and we said, okay, from a leadership perspective, what do you all think in regards to the overall AI adoption? And they started to mention things like, all right, what about the productivity, the level of engagement, how much the organization is actually using the AI and machine learning? And what we saw is that all of that led back to that iterative feedback loop, right? Because the organization wanted to have more KPIs in regards to what would help them make a decision. And then the leadership wanted to have more KPIs on, the decisions that go into resourcing the AI and machine learning. And those together really influenced the overall AI adoption. But for the end users, it was more about what would support me in making a decision. Like, for example, in the National Security Agency, it was all about how could I have enough trust that if I were to make a decision and create a report, right, intelligence community report based upon these insights, that I would have the assuredness that no second order catastrophic effects would happen from that particular decision. So they wanted more insight into the underlying data in order to be able to believe that.
I think you answered. Anybody else for that question, or should we move on? Okay.
Well, the one thing I can say is that I think ground truthing, I love your idea of sort of iterative. I think that's actually really important, and ground truthing the training set, making sure that the results that are coming back are truly aligned with the, I hate to say gold standard data set that you actually are measuring against. That's also really, really helpful. There's a lot of good work that's happening more in the imaging and the ophthalmology and the radiology space, and really looking at what does it mean to ground truth something with AI. And I think that we can learn a lot from where they've made significant progress.
Any other questions? I'm going to walk around here. My best, Jerry Springer.
Yeah, thank you for the talk, and we just wanted to introduce myself, Edward Chesney. I'm an alumni of GW. engineering. Quantum computing and trusted AI. Has anybody looked at that as far as the future as it relates to solving problems? Simple question.
Okay, so I can actually take that one. We have a partnership that we've been working on for about 1.5 years with our Department of Energy. They are probably one of the bigger national lab organizations that are seriously looking at quantum computing and what you can do with AI. I think that there certainly is a lot of opportunities there. Ground truthing is an absolute, because the quantum computer gives you the answer. It is designed to give you the correct answer. So I think that there's a lot of opportunity. We're still looking at how that might be applied to or impact biomedical health, both in the imaging space, the genomic space, and where it's mostly being used right now is sort of in the protein structure space. But it's really, really early days for the integration of biomedical research and quantum computing. So we're still exploring that, although I think that is an absolute possibility in the future, and probably much more so in the NSA world than in the sort of more open biomedical world. So I don't know if you want to take that as well, but there's a lot of opportunities for AI and quantum in that space.
Yeah, one of the really hot topics in the DoD, as well as over at the National Security Agency, is really quantum machine learning, right? And really being able to kind of understand the capability and understand specifically where machine learning and artificial intelligence comes into play, so that you can start to optimize and even further enhance those capabilities. So what we are seeing is a plethora. You can think about the ecosystem for AI and machine learning as far as how individuals engage with AI and machine learning over time has really grown across the board. I mean, we're seeing, at the NSA, when I was there, we started to hire, data journalists and things like, journey architects to help understand and architect the journey for data scientists inside the organization. So when you think about, these types of machine learning technologies, one of the things that I also think about is how that's going to change the way that different personas engage with AI and machine learning across the board. And these DoD organizations are currently thinking about that and trying to figure out how that will actually happen as well.
We have 2 more questions, unless anybody else wants to comment. We'll take one from the remote audience, please.
All right, so next question from online. So there's obvious tensions between responsible or ethical AI and corporate concerns like economic growth or legal matters. And I imagine that there's some concerns in the government and in the research space. How would you advise data and AI practitioners to find that sweet spot between their competing priorities?
I'll take the caustic approach and say that as technologists, sometimes we're in a privileged position where there's not that many people that can build algorithms to do some of the things that we build. And this is a place where we can take a principled stand and say, I will only build the algorithm to act this way. I don't have to necessarily find a sweet spot that balances some corporate interests and some privacy concerns. I can just say, as a technologist, I'm going to work only in the space of algorithms that preserve the privacy. And I think that may be a difficult thing to do, and it may create some conflict in your workplace, but it's a principled approach that can have really high value at this high leverage moment when we're building the foundations of these things.
And I think one thing to really keep in mind for a lot of these organizations across industry and the federal government is that there's a balance between the risk that's associated with AI and machine learning and the actual speed of innovation as well. And what we're seeing is that these organizations are on the different ends of the spectrum. So think about like in the DoD and the National Security Agency, you saw a very small number of machine learning and artificial intelligence capabilities that made it into a mission production application. But then fast forward, we go into a lot of organizations, Fortune 100, Fortune 500 companies, And they have, risk models that have been built in to really assess risk. And what they're assessing is, if we put in place a machine learning algorithm that makes a fully autonomous decision, what's the level of impact that a wrong decision could actually have, right? So, when you think about organizations like the National Security Agency and the Department of Defense, a wrong decision could have extremely catastrophic effects. And that's why you see a very small number of machine learning capabilities that are being deployed, not only from a perspective of a human in the loop actually taking the results of that machine learning algorithm and making a decision, but you're talking about an even a less number of fully autonomous AI and machine learning algorithms, because there's the inability to point back to an individual to say that was the individual that built the model that made the decision, because in that case, there's no attribution, right? And when you go to the Office of General Counsel and you say, in front of the lawyers that we don't know who made the decision, it was the algorithm, it's a non-person entity, that could be very bad, right? In a legal situation. They need that attribution. So that balance between risk and innovation is really important, but a lot of times that the high levels of risk could slow down innovation in organizations and really kind of handicap a lot of the mission, right, that's necessary in these organizations as well.
We have one more question from here in the room, and then we'll conclude. I'll turn it over to Dean Locke to close up.
Thank you. Thank you for this great conversation. My name is Kafuti Talawumbu. My question is around the policy and the regulation. As we're moving forward, do you believe there will be a need of an organization like the FDA that will have to go to approval process before a company can deploy an application large scale? Or do you believe those type of organizations will prevent innovation and growth and slow innovation here in the US?
Yeah, that's a great question. To deploy AI in the healthcare sector, you do have to go through an FDA approval process, including vetting and validating and verifying your algorithm and the outcomes and the trials that you've had to show that it is trustworthy. So there is a pretty high standard for getting AI deployed in the healthcare sector that I think will continue. The question, more for maybe the administration is, for AI generally, what are the policies and the regulations that we would want to have? There's a great AI Bill of Rights that was put out just recently by the administration. The rights that we have as participants or people in having our data used in AI and making sure that it does no harm to us or to our communities. And so that is something to think about and look at, but I think that's still under discussion.
Well, thank you. We'll be good custodians of all of your time and bring us to a closure. If Dean Locke wants to come up and close up, and I forgot to actually start out today's discussion with my wife's economist, which has this neat, it's almost as if they expected us to be speaking today, AI with the angel halo and the little devil thing going on. And we've covered a lot of that today. So thank you for all this. Thank you to our distinguished speakers for joining us today. Dr. Locke.
Great. Thank you so much, Todd. And thanks again to the speakers. Let's all give them a hand. What a wonderful conversation. Really honored to have such wonderful experts in the room to share your perspective. And also, I want to thank CVP and Anirudh for having the vision for creating the speaker series in the first place. As he introduced, this was created with the idea of having really important conversations at the intersection of technology and society. And I think it was very clear today that that's very much the kinds of conversations that need to happen in this space. As I often say when talking about the work that we do here around trustworthy AI at GW Engineering is that trust is not just a technical problem to be solved. It does require the engagement of all these other disciplines. And fortunately, being at a university like GW and in a city like DC, there's all these opportunities to interact and collaborate across disciplinary boundaries and with a wide variety of organizations. And as Dr. Pless said earlier, our mission here at GW is that combination of research and education, and always with that goal for positive societal impact. And so with that research we're doing here in AI and the education that we're giving our students in AI, it's always with that added dimension of societal good. And so when we think about issues of trust with AI and what that really means, including across different communities. I mean, there's thinking about from country to country or even community to community within our own country, very different notions of how is it that we trust something. And so having engagement through the development of these systems and the way that they're being used in our world is just so important. And I'm really proud of the work that our faculty and the students are doing in this space, and honored to be able to collaborate with NIH and many of the other federal agencies in the area to really have that positive societal impact. So thank you again for coming. Thanks to everybody online. I think we have a good online turnout as well. And again, thanks again to the panelists and to CVP for helping to make this possible.